Okay guys, welcome to another video. Today we are going to solve this limit using squeeze theorem. So first of all, we know that sine, this function sine, is sine of what? N square. It's between this interval -1 and 1. So what we have here in the denominator, I mean not denominator, numerator, we have n. So we are going to add n here, and then we get sine of n square, right, plus n, as we are adding all these here, so we get plus 1 plus n, right? Now we have this is equal to this, right? Now we want this. Consider that n is positive and it goes to infinity, so we can divide this without worrying about here. So we are going to divide every single side by let me write this again so that you can understand. But it's really simple to solve these limits. Most of the time when we get sine, we can think of this theorem. So here we divide, we get cosine of n, we divide here, cosine of n plus here, don't forget, n plus cosine of n, right? Okay, good. Now I'm going to divide numerator and denominator by n. So what do we get? We get -1 divided by n. We get here 1. Here when we divide by n we get 1. Here when we divide by n we get this, right? So this is what we want. So I'm going to keep like this first. And sine of n square plus n, then cosine of n. Here we get 1 and plus cosine of n, right? So I'm going to plug in the limits now. So what we get? My dog is barking. Oh my god. Okay, go on. Yes, guys, you had better forget about these sounds of my dog, you know what it's doing. So keep on. We are going to plug in limits every single side here. Limits when n goes to infinity of this, let me write here, plus 1 plus cosine of n divided by n here is less than this. I'm going to plug in limit when it goes to infinity. Hey, it's infinity, this, just you to understand. Sine of n square plus n over n plus cosine of n, it's less than, here we plug limit and n goes to infinity. Oh my god, I forgot here to divide. Okay, let's divide this. Let's divide this. 1 over n plus 1 plus cosine of n divided by n. So what do we see here? Let me write here, we get 0, right? And plug in infinity, here we get 0. So the deal here is this limit. Again, we are going to use squeeze theorem. So we know that we need now this limit. We know that cosine of n this function is less than is greater than -1 and is less than what? 1. Of course, it's n here, so we are going to divide by n every single side. Here we get 1 over n, and less than is less or equal, it's less or equal here, cosine of n divided by n. Here we get 1 over n. Now we can plug in limit when it goes to infinity, minus 1 over n here, because it's what we want here, this limit when n goes to infinity. So we get here n tends to infinity, I get cosine of n divided by n is less or equal to this limit when it goes to infinity, n goes to infinity, 1 over n. We know that here we get 0, so it's less than this limit, yeah. Then we get 0. So which number is between 0 and 0? This must be 0. So this limit and n is infinity here, and tends to infinity. This limit of cosine of n over n, it's equal to 0. Yeah, it's equal to 0. Yeah, it's that. So what we do, we now know that it's equal to 0 if we get 1 here. 1 over 1, it's 1, it's less or equal to this limit, and when it goes to infinity, sine of n square plus n divided by n plus cosine n. Cosine of n is less than, here we get it's 0 here, so we get 1. So the same explanation that I've just given. So we conclude that this limit, it's equal to what? Yeah, we come back here, it's equal to 1. So that's the answer.